Hello everyone, welcome to all in this lecture. In this lecture, I'm going to discuss center of gravity of plane figure by integration method. In the previous lecture, I have discussed what is centroid, what is center of gravity, and how they are two are in the same thing. For this area, centroid and center of gravity will be same. I have also discussed for various shape of figure like rectangle, triangle, semicircle, hemisphere, right circular cone, circular sector, right angle triangle. I've discussed their center of gravity, their position of center of gravity, and also I've discussed center of gravity of a plane figure by method of moments. And also I've discussed various application of center of gravity in the daily life. In the real life, you have seen at many places there is a concept of center of gravity. In this lecture, I'm going to discuss center of gravity of plane figures by integration method. Center of gravity of plane figure by integration method. So in the moments of method, I have discussed like x bar would be summation of xi ai into divided by summation of ai, and for y bar summation of ai yi divided by summation of ai. So there x bar is the centroid, it is the distance of centroid of whole area from the y-axis. Okay, and where the xi, that is x1, x2, x3, x4, and so on. So these are the, for example, x1, this is the distance of centroid of first segment, their area is a1. So distance between the centroid of first segment to the y-axis. Similarly, x2 is the distance of second segment, the distance of centroid of second segment from the y-axis, from the y-axis. Similarly, yi, y1, y2, y3, and so on. So y1 is the centroid distance of first segment, centroid of first segment from the x-axis, and where the ai is the a1, a2, a3, and so on. So if suppose we will divide a number of segment and then n is the infinite, it means we will divide the area in infinite number of segments. Infinite number of segment. So what will happen? The a1, whatever, that will be very a small area. Like a2, a3, a4, a5, all will be very small area. So we can write ai, we can write da. It means very small area. Very small area. So in this case, we will see, and we can do like some x bar will be, we can convert summation into in integration, right? So this summation will be convert in integration. Ai would be dA, and xi will convert into x dash. Similarly, summation of ai will convert integration of dA. Finally, we can write x dash dA divided by dA. Similarly, y bar we can write integration y dash dA divided by integration dA. So where x dash. What is x dash? So x dash is the distance of centroid of a small area, that is dA area, from the y-axis. Distance of centroid of small area, we can say dA area, from the y-axis. Similarly, y dash will be distance of centroid of dA, that is a small area, from the x-axis. Okay, so this is the uh, equal to x bar. So now to use the integration method, we will remember this formula for calculate x bar, and for calculate y bar, we will remember, you have to remember this formula. Yx dash is equal to integration of x bar is equal to integration of x dash dA divided by integration of dA. Y bar is equal to integration of y dash dA divided by integration of dA. Okay. So now by using the integration method, we will calculate the centroid of a rectangle. Okay. So I am assuming one axis. Suppose this is the y-axis and this is the x-axis. This is the length of rectangle section and this is the width of B I'm writing, width of the rectangular section. Okay, so we have to calculate x bar. Suppose centroid somewhere, I'm assuming somewhere here. So this is the centroid and this distance will be x bar and this distance will be y bar. Okay, now x, we have the formula x dash integration of x bar is equal to integration of x dash dA divided by integration of dA. Similarly for y bar, integration of y dash dA divided by integration of dA. Now from this figure, first calculate, I'm writing, we have to take one small segments. So I'm taking a small segment somewhere here. I'm saying taking this segment. And the centroid distance from the x-axis, that is y I'm assuming. That is variable y. And their thickness or their width will be dy. dy. It means we have the strip this one, and from the x-axis their distance is y and their width. Okay. So now from this figure we can write dA, area of a small segment. So this is the area of small segment. So what will be the area? You can see this is the rectangular in shape. So area would be, what is this length? This length is L. You can see in this figure, this length is L. So we can calculate dA L into dy. L into dy, where L is the length of this rectangle. Okay, now I will put the value in this y bar. Okay, integration y dash. What is the y dash? Centroid of small or segment from the small area segment from the x-axis. So that we have y. So y dash we can write y. dA, at the place of dA we can write L into dy. L into dy. See here the integration and here the differentiation. This is the differentiation or this is the integration. So automatically Finally, it will become A, where the A is the total area of rectangular portion. And what is the A here? What is the area of rectangle? Length into width, so L into B. So this is the total area. Okay. Now, integration, L is constant, so we will take the outside. L is constant, we'll take outside y dy. In denominator, there is a capital A and capital A is L into B. So we can write L into B. Now, L will cancel. So we can write here integration of y dy divided by B. What is the integration? Y, integration of y with respect to y. Okay, so we can write d square by 2, and we have to set the limit. See, while to complete the rectangle, while will when this segment will be here, so y will be 0. When the segment will be here, so y will be b. So means y will vary 0 to b. Upper limit will be b, lower limit will be 0. So we can write b square by 2 minus 0. So what will come? B square divided by 2b. B will cancel, it will come b by 2. Means y bar we get b by 2. Are you getting a point? So here y bar will be b by 2. Similarly, we can calculate x bar. So this is the y-axis, this is x-axis. Okay. Now to calculate x bar, suppose here G, I am going to take a small segment parallel to the y-axis. Why I am doing this? Because one, you will get this. So there x dash will be constant, right? So this will be x distance from here, and their width of a strip is dx. So from here, small area we can write for this strip. What is the length? Here b. And what is the width? dy, dx. So we can write b into dx. And what is the area here? Total A. Total A means total area of this figure, rectangular figure. So this will be L into B, right? So now what we have formula? X bar integration of x dash dA divided by integration of dA. Now put the value of this x dash. So x dash is the distance of centroid of small segment or small area segment from the y-axis, that is x here. So we can write x dy, we can put b into dx. See, this is the integration and this differentiation, so it will cancel, it will become a. So now here in this integration, b is constant, so we will take outside b integration of x dx divided by, put the value a, that is lb. So b will cancel, we can write x dx divided by L. Now we can write integration of x dx. So it will be x square divided by 2. What will be the limit? Limit will be, see, when this will be here, so x will be 0. When segment will be here, so here x will be L. means upper limit will be L and lower limit will be 0. So it will come L square by 2 minus 0 divided by L. So from here we can write L by 2, that is x bar, means here x dash will be L by 2. Okay, so this is the integration method that I am using to calculate the center of gravity. Center of gravity of a triangle. In the previous lecture, I told you that this is the right angle triangle. It's called right angle triangle because one of angle is 90 degree. This is 90 degree. Okay, suppose it length each, this height is h and this width is b. So in the previous lecture, I told you suppose g is the center of gravity. So this will be, okay, means the y bar. Suppose this is the y-axis, this side, and this side is x-axis. So y bar will be equal to h by 4. Sorry, h by 3. H by 3. Okay. So that we will see how it will become. It will become h by 3. Okay. So what we will do to calculate the x bar, we will take a segment. I am taking here. This is a small segment. From the x-axis, the distance is y. Okay, and this width of this is dy. Means whatever we have selected is like this. Width is dy, and from the x-axis, distance is y. So from here we can write dA is equal to area of this small segment. So length into width. What is this length? That we don't know. Okay. Suppose this distance is b dash, for example, b dash. So dA will be b dash into dy, right? Okay. Now this distance is b dash. So how we will calculate? So from the similar triangle, like similar triangle of this, uh, this is h, this is b, and this is b dash. So what will be this value? So this total is h, and from here to here that is y. So this will be h minus y. Am I right? Okay. So from the similar triangle, we can write h minus y divided by b dash will be equal to h divided by v. So from here we have to calculate v dash. So what will be the b dash? We can write h minus y divided by b into h. We can write b dash is equal to h minus y divided by b, sorry, into b. Okay, wait. Now, okay, so h minus y divided by h into b. Okay, so b dash we can write this. Now, calculate y bar. We have the formula integration of y dash dy divided by integration of dA. Okay, now put the value of y dash. What is the y dash here? Y dash is the centroid of a small area segment from the from the x-axis. So y dash will be here y. So integration of y dy. We can write b dash dy. and integration differentiation of A, it will be A. And what is the A here? A is the total area of triangle. So that we know half into B into H, or we can write BH by 2, BH by 2, that we can write. Okay, so now I'm putting the value B dash and A. So y, B dash is H minus Y divided by H into B into dy, divided by area, that is BH by 2. Now, in this integration, you will see H and B is constant. So we can take outside. So outside we can take B by H integration Y into H minus Y into dy divided by BH by 2. So here you can see B will cancel. So it will become B divided by H square. Now integration H Y multiply Y and Y square. Now 2 divided by H square, what will be the integration? H is constant, so it will become H Y square by 2 minus Y cube by 3. What will be the limit? See here Y, suppose this segment is here, so here Y will be 0. हेलो, बढ़िया हूँ सर। मल्लाथपुर जी, अवंतीपुरा। मेरे पास तो प्रेजेंटेशन नहीं है। सिविल डिपार्टमेंट से ना, तो अभी प्रेजेंटेशन तो बना नहीं, हमारा तो 24 को है। मैकेनिकल का 28 किया उन्होंने, और कुछ नहीं किया अभी। हाँ, पता नहीं सर, मुझे नहीं पता अभी। सर अभी उसमें जो है ना हमारा एक 3 1.5 घंटे का है एक्चुअली। डिपार्ट सही है, उसमें 3 है डिपार्टमेंटल विजिट, ठीक है। एक डिपार्टमेंटल विजिट में आता है कि आप अचीवमेंट्स, डिपार्टमेंटल अचीवमेंट्स, ठीक है। डिपार्टमेंटल अचीवमेंट में आता है फैकल्टी अचीवमेंट्स। तो हर फैकल्टी को 5-5 मिनट का मैं स्लॉट दे रहा हूँ, 5 से 10 मिनट का। वो खुद पीपीटी बनाएंगे, ठीक है। उनका इंट्रो भी हो जाएगा, और मेन अचीवमेंट्स में उनका फोकस रखना है, लाइक उन्होंने कुछ किया है, लाइक पेपर पब्लिश, पेटेंट्स वगैरह, ठीक है। या इंस्ट्रूमेंट वगैरह कुछ नया मंगाया है, कुछ अपना कुछ किया है कॉलेज में, रिसर्च वगैरह, या उनका कुछ है अपनी एबिलिटी, तो वो दिखाएंगे तीन तीन से चार स्लाइड में, ठीक है। उसके बाद है स्टूडेंट का अचीवमेंट्स। तो वो स्टूडेंट है नहीं यहाँ पे, तो वो हम दिखाएंगे गेट स्कोर या गेट वागे, इंटर्नशिप के लिए गए हैं, या कुछ बच्चे यहाँ से डायरेक्ट जॉब लिए हैं, कुछ उसमें हेल्प हुआ है, तो वो स्टूडेंट का क्या अचीवमेंट्स हुआ है, तो स्टूडेंट को हम क्या दे रहे हैं एट द एंड। तो अगर हमने उसमें कुछ बना के रखा है तो वो दिखाएंगे। और फिर थर्ड है लैब में, तो उसके बाद लैब में ही ले जाएंगे बच्चों को, जहाँ फैकल्टी को इंटरेक्शन करेंगे। स- सर ये डिपेंड करता है कि हम कहाँ चाहते हैं। जैसे मैंने बोला था, मैंने सर को बोला हूँ कि ऑडिटोरियम में कंटिन्यू कर देंगे बच्चों को, हमारी फैकल्टी वहीं प्रेजेंटेशन दे देगी। हाँ, वो खुद ही एक, देखिए इसमें क्या है ना, फैकल्टी इंटरेक्शन भी है ना, तो फैकल्टी के साथ इंटरेक्शन भी हो जाएगा। ठीक है, ठीक ठीक। So what will be the limit here? So you can see when y segment is and this level at the bottom level, so there y will be 0, and when segment is here, so y will be equal to h. So limit will be vary 0 to h. Okay, so we can write here. Let me erase something. Okay, so we can write here that 2 divided by h square uh, into h square divided by 2 minus h cube divided by 3. So you will see by solving you will get 2 divided by h square into h cube divided by 6. So from here you will get h by 3, means y bar is equal to h by 3. Similarly, after solving we can get that x. Similarly, you can get support this length is b. So centroid suppose here. So you will get x bar is also b by 3. Do the same procedure. Y bar is h by 3 if this is h. But what we have to do to calculate x bar, you have to take the segment parallel to y axis. To calculate segment, you will take like this. So by taking this segment, you can calculate x bar, and it will come b by 3. Okay. In that, suppose you are working, you can x you are taking like this. So in this case, you will see x the lower limit will be 0, and upper limit will be b. Okay. So by doing the same procedure, you will get x bar is equal to b by 3. Okay. Now come to the semicircle. So by using the integration method, we will calculate center of gravity of semicircle. So see by this I am taking here. This is x, this is y axis, this is x axis. Okay, so due to symmetry, because on the for this y axis, you will see according to y axis, this figure is symmetry. So center of gravity somewhere will lie here. Center of gravity will be lie here. Okay, now we have to calculate this value. What will be the value of this? Means this y bar. Y bar. So we have calculated y bar, and here this radius of this circle is r. Okay, so what we will do, take a segment, a small segment somewhere here, and their distance is y. Okay, and their width of this small segment will be dy. Now problem is what will be this. So I'm taking this this would be r dash or a small r. Okay, so what will be the dA? dA means area of a small segment. You will see width is dy into total length. This is a r dash, so this will be r dash 2. Okay, so total will be 2 into 2 times r dash, or we can write d8 is equal to 2 r dash into dy. Okay, and what will be this r dash? So see, this length will be capital R because this is also radius. This is the y, so we can calculate from here by using the Pythagoras Prameya. We can write this r dash is equal to root under of r square minus y square. So from here also we can write dA is equal to dA will be equal to r dash, that is root under r square minus y square into dy. Now, what is the formula to calculate y bar? So integration of y dash dA divided by integration of dA. So now we can write y dash, that is centroid as a small segment from the y x-axis. So that will be y. Now dA. So dA is 2 into root under r square minus y square into dy. Divide by integration or differentiation of a. So it will be a. And what is the area? Total area of this. This is the semicircle, means half of area of circle. So area of circle is pi r square. So we'll take. So area would be half of pi r square. Now 2 is constant, so we'll take outside. So 2 divided by area, that is pi r square divided by 2. Now integration of y root under r square minus y square into dy. Okay. Now to calculate this, we have to take for example here r root under r square minus y square. I'm assuming t square. Okay. So differentiate y and t also. Taking differentiation on the both the side. Taking differentiation on both side. Taking differentiation on both the side. So what will come? See, r square is constant. So differentiation of constant will be 0 minus 2y dy is equal to 2t dt. Right? So from here we can write minus y dy, or we can write plus y dy is equal to minus t dt. Okay. So now put the value of this. Now I'm writing here this 4 divided by pi r square integration of root under r square minus y square y dy. We can write, okay. So 4 divided by 5 r square integration root under of r square minus t y square. We can write, see here, r square minus y square is equal to t square. So we can write root under of t square. Y dy, we can write minus t dt, minus t dt. Okay. Now, okay. So we can do the integration. 4 divided by 5 r square integration of root under of t square. So it will be t into minus t minus t into dt. Okay. So this will become t square. So minus will take outside. So we can write minus 4 divided by 5 pi r square into t square dt. And for t square dt, we know the what is the integration? That will be tq divided by 3. And again t, whatever we have taken the assumption, put the value of t here. So that we can write minus t divided by pi r square. Put the value of t, that is root under. So we can write r square minus y square to the power root under. That means power is 1 by 2. So we can write 3 by 2 divided by 3. Okay. Now, so we can write here. So finally, integration is minus 4 divided by pi uh, r square minus y square to the power 3 by 2. After putting the value of t, divide by 3. What will be the limits? So lower limit when the segment will be here. So y is equal to 0. When the segment will be here, y is equal to capital R. Okay, because this y is vary from 0 to R. So upper limit is R, lower limit is 0. Now minus 4 by pi r square into, first put the value of r square. So r square minus r square will be 3 by 2 minus, now put the value of lower limit, that is r square minus 0 square to the power 3 by 2. So this will become a 0. So finally will become minus 4 divided by pi r square into minus would be 0, that is r square to the power 3 by 2 divided by 3, right? So minus minus would be plus 4. See here r square 2 will cancel, here r cube. So it will become 4r divided by 3 pi, that is y bar. By doing the integration, you have to focus, you have to take care about the dy. What will be the dy? And you have to take that segment, a small segment, in what direction. So you always have to be remember, like whenever you are going to calculate y bar, you have to take the segment parallel to the x-axis. Okay, you can try also, you will get the same result, 4r by 3 pi. Okay, these are the reference that I've taken to make this lecture. Thank you. Thank you everyone for watching this lecture. So in the next lecture, I will show integration method for calculate the center of gravity for different shape of figure. Okay, thank you.